Please open to page 102 of your learning workbook as we continue by solving some problems involving properties of exponents where those exponents happen to contain fractions. Let's read a problem. Use properties of exponents to simplify the expression. Write with positive exponents. Assume that all variables represent positive real numbers. The first thing I notice about this problem is the instructions contain the phrase, use properties of exponents, which tells me that I will not use the radical symbol as part of my solution to this problem. So, what will I do instead? I will use properties of exponents, the 8 rules that we learned about previously, were the ones that were color-coded in red and blue and green. This problem needs to be simplified, and the hint is that we should use this rule first. So, let's take a look at what we have. This rule says, when two things in parentheses are being raised to an exponent, then each one of those things gets raised to that exponent, and then they get multiplied together. So that's what we're going to do here. The two things that are inside the parentheses being multiplied are the 16 and the u squared, and each one will be affected by this exponent of 3 halves. So we have 16 to the 3 halves power, u squared to the 3 halves power, and then those two things are going to be multiplied together. Notice the use of parentheses around the u squared because we want the entire exponential expression to be raised to the 3 halves power, not just the 2. Okay, now we have to attempt to simplify each of the 2 pieces of this problem. Let's go to our side workspace and start working on this number first. We learned in a previous video that when an exponential expression has a fraction as its exponent, that can be rewritten in 2 different ways. But one of the ways is generally easier than the other. It was the one at the far right end, and that's the one we're going to use here. The denominator of the fractional exponent tells you the index of your radical. So this is going to be a square root. The base is 16, and then the numerator can be applied to the entire radical. Now, normally we wouldn't write this 2. We would simply say that that is the square root. So, let's erase it. We note that the square root of 16 is 4, which is being raised to the 3rd power, and 4 cubed equals 64. So this part of our problem is 64. Now we move to this part of our problem. Well, another exponent rule that will be helpful to us here is when you have x raised to the m and then raised to the n power, you multiply the 2 exponents together. So we get x to the m n power. In other words, we're going to write this as u raised to the power 2 times 3 halves. And we can do a little fractions math to simplify this. Let's do it in our side workspace. 2 times 3 halves can be written as 2 over 1 times 3 halves. And if you simplify before you multiply, those 2's become 1's, giving us the result 3. So this new exponent is a 3. So our final answer is 64u cubed. Okay, let's try another problem. The directions are the same. Use the properties of exponents to simplify the expression. Write with positive exponents. Assume that all variables represent positive real numbers. All right, we have a fraction. In the numerator, the base is x to the 5th times z. That's all in parentheses being raised to the exponent 1/10. In the denominator, we have x to the negative 1/2. And that's being multiplied by a z to the positive 1/5. Okay, let's see if we can solve this problem. The first exponent rule that I recommend that we use is one that we used in the previous problem. We have two things in the parentheses, both being raised to the same exponent. Each one of those things will be affected by that exponent. So changing only the numerator of this problem, we would have x to the 5th raised to the 1/10th power times z raised to the 1/10th power. Notice that I need parentheses around x to the 5th because it's an exponential expression, but I don't need parentheses around the z because it's just a single variable. I'll leave my denominator the same for now. The next rule that we should apply is the power to a power rule. When an exponential expression is raised to a power, you multiply the two exponents. So this gives me x raised to the 5 times 1/10th power. All of the other elements of the problem remain unchanged for now. Okay, we need to do a little fractions math. We need to figure out what is 5 times 1/10th. Well, 5 times 1/10th could be written 5 over 1 times 1 over 10. And we can simplify 5/10ths to become the number 1/2. So my new exponent on x is 1/2. All other elements of the problem remain the same. This illustrates an important characteristic of how math is written. Very often, we make just one simplifying step at a time, leaving all other elements of our problem the same. This allows us to create clarity in the presentation of our solution. Okay, the next rule we're going to use is a fractions rule. We're going to use the rule for multiplying fractions in reverse. And we're going to use it to split this one fraction into two pieces. We'll have x to the 1/2 power divided by x to the negative 1/2 power times z to the 1/10th power divided by z to the 1/5th power. The reason why we want to split this into two fractions is so that we can take advantage of another exponent rule. The exponent rule that says when you divide two exponential expressions with the same base, you get just one exponential expression, and the new base is these two exponents being subtracted, top minus bottom. In other words, x raised to the 1/2 minus negative 1/2. Similarly, z raised to the 1/10 minus 1/5. Okay, let's continue our simplifying by working with these fractions. What is 1/2 minus negative 1/2? Well, we know that subtracting a negative is the same as adding, so this must be the same as a half plus a positive half, and a half plus a half makes a whole, or simply the number 1. So this is x to the 1st power. Normally we wouldn't write an exponent of 1, but this is not our final answer, so we'll write it there for now. Now we turn our attention to the 1/10 minus 1/5. To add or subtract fractions, you need a common denominator. Let's create one now. 1/10 minus 1/5. The denominator of 5 needs to be turned into a 10, and we can do that with multiplication by 2. But if we multiply the denominator by 2, we must also multiply the numerator by 2 so that the fraction retains its value. Therefore, we have 1/10 minus 2/10. Once the denominators match, we simply subtract our numerators. Our answer is going to be in terms of tenths because the denominator tells you the type of thing you have. The numerator tells you how many. 1 minus 2 is negative 1, so we get negative 1/10 as the exponent of z. Okay, we're almost done. The last thing we have to do is get rid of this negative exponent using the rule a to the negative fraction is the same thing as 1 over a to the positive fraction. Okay, so x over 1, that's just going to be x, times z to the negative 1/10, which we'll write as 1 over z to the positive 1/10. And now, if we treat this x as x over 1 and multiply across, we get our final answer, x over z to the 1/10 power. We used several exponent rules, as well as several fractions rules, to answer this question, and it required a lot of steps. Be patient when solving problems of this type.